Alright, hi everyone. Today's Tuesday, May 5th, 2020. Today we will be able to explain the environmental impact of medications and green chemistry. This is actually the last section of medicinal chemistry. All month we've been talking about different medications and different medicines, tackling various different diseases or viruses, etc. And now we're going to talk about their environmental impact and a branch of chemistry called green chemistry, and counteracting this impact. So first, we want to talk about the waste, the negative impacts that our medications have had on the environment, and then we'll end off with green chemistry. And really, throughout the whole lesson, we'll talk about green chemistry and how we've tried to counteract this. For the assignment, the last thing is to do the practice paper 3 questions on green chemistry. The handout is on Google Classroom. So environmental impact. So really, we're talking about the waste. Okay, so through this unit, we've explored many ways in which modern medicine has made a lot of significant contributions and advances in human health. And just like how side effects of medications can impact health, there's actually quote-unquote side effects of the activities of the pharmaceutical industry and its impact on the environment. So we're going to talk about solvent waste. So a lot of our reactions require the use of something to make something soluble. So this is our solvent waste. Nuclear waste, we talked about nuclear chemistry last week, and there's a lot of byproducts as a result of doing those chemical reactions. And we also have antibiotic waste from our antibiotic section earlier in the unit. So first, let's talk about solvent waste. So most drugs, most of the medicines we've been talking about, they're very complicated molecules. We've seen a lot of these structures. They're not small. They're quite elaborate. And making them, as we've seen, so their synthesis requires a lot of organic solvent use, which is a major concern in the pharmaceutical industry. So what are its concerns? Well, of course, we care about people who have to handle it. So it's very they care about the toxicity to workers, and a lot of the big questions to the chemicals they're handling is it carcinogenic? And carcinogenic is just another word for saying, will it cause cancer? So I've talked about my experiences a lot in research, and one of the first things you learn while you're in research is proper handling of chemicals. And I've dealt with chemicals that were very dangerous. Some were carcinogenic. Some had the possibility of even exploding in my face, and that actually leads to the next one: the safety of process. Safety is huge. So in my training, every time I learned a new reaction, my professor had to make sure that if I was dealing with a very dangerous setup, he would let me know. And I still remember it to this day. There's one setup that is very explosive. But it's okay, because if I was able to be aware of my surroundings, I can minimize or even not have any of those dangers be present. But as you can imagine, on a very, very large scale, it needs to be very safe, and I assume that risk is not worth taking, especially at a big pharmaceutical company and an area like that. And also, harm to environment, will it contaminate the surroundings? right? Maybe the biggest offender that you can think of is maybe you think of like power plants, and they have a lot of like carbon emissions. So this is very similar with solvents. Is it going to contaminate the surroundings? So how does green chemistry play into this? It focuses on the use of safer solvents when possible. So if you can think about things in your experience that is able to make things soluble, the first thing that that comes to mind is water. And whenever we can, we want to use water in our reactions. And you might ask yourselves, why don't we just use water all the time in our reactions? A long story short, it's very complicated, but water is actually not that great of a solvent in many chemical reactions, because a lot of reactions are water sensitive. So it's avoided for the most part, but in the industry, if we can get away with using water, of the few times that we can, we definitely utilize it. Let's move on to our next section. So we talked about nuclear chemistry, and of course it has some waste associated with it. So the use of nuclear chemistry and its reactions and its techniques actually lead to a lot of radioactive waste. We will always focus on one of the product and say, oh, hey, this is this is the thing that is has therapeutic effects, and then we sometimes just forget about the other products. But those other products, often in this field, are actually very concerning as waste products. Okay, so we see that they're potentially hazardous to humans, and not only to humans, but our surrounding environment. So what is important in this industry, and when I mean industry, it's really the medical industry that uses a lot of the, our radioactive or radio therapeutic drugs. So proper disposal is a major concern. We have two types of waste. One is called high level waste, and kind of how it comes from is large amounts of ionizing radiation, and this radiation occurs for a long time. And the opposite, low level waste, is small amounts of radiation for a short time. So for both of these wastes, they're definitely toxic and radioactive. So that means it has a lot of damaging effects to the environment. And we were talking about how nuclear chemistry, is focused on unstable nuclei, and how they break apart or decay into smaller and more stable nuclei. So that decay process, we didn't really talk too much about the energy involved about it, but it produces a lot of heat. And it's not a negligible amount of heat. It's actually a lot of heat that we actually try to store these underwater. Water is a good absorber of heat, and sometimes we also store it underground in heavily shielded areas. So if you think maybe in movies, sometimes they have underground bunkers. That's basically what we do with a lot of those byproducts. We store them underwater and underground, and though we don't talk too much about it, maybe the first thing you think about is, don't we have a limited space underground? And yes, we do. So there's definitely places like in deserted areas where a lot of these things are, but if those things are not able to be removed in a better way than just kind of quote unquote hiding them underground, we're gonna run out of space really quick. So this is a big concern for green chemistry. So we're really trying to focus on reducing the nuclear waste, and really by doing that, we're trying to replace those radioactive isotopes whenever we can with more environmentally friendly substitutes. So that might mean just, not using nuclear chemistry when we do not need it, because it is very damaging to our environment. In terms of antibiotics, so this goes back to one of our first sections in medicinal chemistry, antibiotics and their waste. So we talked about it during then, but the problem of most antibiotics is the evolution of antibiotic-resistant bacteria. I made it dramatic with the war, where we have a bacteria disease. We created an antibiotic to fight that bacteria, but over time, evolution plays its part, and bacteria evolve to become resistant to that. But a weird side effect of all of this, this is not the side effect, but these bacteria sometimes are no longer effective as therapeutic agents. But what I was trying to mention is that we found that antibiotics were so successful that at a given period, we had a large-scale commercial production of these antibiotics, and it's led to millions of tons of antibiotic compounds released into our atmosphere, and really just have too much of it that had now become ineffective because they are bacteria's become resistant to it. So this leads to improper drug disposal, whether after use or just simply they are expired or no longer effective. So this leads obviously to contamination of surface, ground, and drinking water supplies, along with just affecting our environment. And really, last but not least, this is the last section of this part. We talked a little bit about green chemistry throughout, counteracting some of these problems, but I wanted to showcase some of these success stories that IB has presented in the pharmaceutical industry. So number one, the production of the drug Viagra by Pfizer uses a modified synthetic route that produces a quarter of the waste of the original. So this is actually one of the most sold drugs in the world, and its original synthesis, so kind of breaking down the statement here, was quite lengthy and quite, difficult. So because it's long, that means multiple steps require a lot of, compounds to be used, and we talked about solvents. So if you are able to use a different pathway, which Pfizer was able to do, they were able to reduce the amount of waste used. So you'll see in all of these stories very similar ideas. So here, reduce amount of solvent and avoids toxic reagents whenever possible. So similarly, the synthesis of the pain reliever ibuprofen uses a 3-step synthesis down from the original 6 steps. And by step, I really just mean 6 reactions to make the ibuprofen versus 3. And just like before, if you can just make things shorter, it increases the amount being made while also using less energy in your processes. And last but not least, synthesis of the analgesic drug Lyrica uses a natural reagent of an enzyme with water as a solvent. So anything we can use stuff from nature directly. So in this case, it uses a natural, product of an enzyme. In addition to using water as a solvent, the better for our environment. So here it reduces the use of non-renewable organic materials. And also, it reduced a lot of the emissions, so more than 3 million tons of carbon dioxide. Remember, CO2 is just is one of those greenhouse gases, and the more that we can eliminate or reduce those emissions, the better it is, for our environment, especially in a time where climate change is such a huge factor, and we're going to start hearing about it a lot in the next upcoming years, because it's one of, if not the most important problem that we need to face as a, not just a country, but really as a whole Earth and world. So we'll see how that goes. Other than that, that is it for today. I'll upload this in a moment. The assignment is to do the questions on green chemistry, so that's on Google Classroom. Yeah, that's pretty much it.